For project one, I read the article, The Effect of Neurofeedback and Electromyographic Biofeedback Therapy on Improving Hand Function in Stroke Patients. So to start off, we have to define what a stroke is. So a stroke would be the removal or total loss of blood flow within the brain. This could be through an artery or a capillary. And we have two types. We have the ischemial stroke, which could be through a blockage, or we could have a hemorrhage of the blood vessel, which would be a hemorrhagical stroke. So why would this be important? Because of the localization of the brain. We learned earlier in this class that there are different functions localized to different areas of the brain, though there's a network of functions that we can describe to. But if we have damage to a local area, we know that it could have a specific function. It could determine almost a prognosis of what somebody could be displaying. So for this study, we had 30 participants. The 30 participants all had strokes, and all of their strokes resulted in the loss of hand function. So if we go back to our earlier slide, we know that the sensory motor cortex is where we get a lot of our motor cortex. So we could say that there could possibly be some damage there, but it could also be localized outside that region. So to treat these patients, we set them up into 3 groups. There was our control group that only did occupational therapy. This would be the typical treatment that would be given to someone that has had a stroke. So they received occupational therapy. Our second group, our OTBF group, was the group that received occupational therapy as well as biofeedback. And this was EMG biofeedback. And then our third group we had was occupational therapy as well as neurofeedback. So for all 3 of these groups, they all did 10 sessions of occupational therapy. And after those 10 sessions, they went into their each respective other therapy. To start all of them off, they did the Jepson hand function test. And this hand function test was to get a baseline of hand function for all the people. This was before they did any of the occupational therapy, any of the sessions. So once that was acquired, they put them into the groups and they went from there. So the first group was our control. So they only went through occupational therapy. Our second group was occupational therapy, but did the electromyographical biofeedback. So what this is biofeedback that can tell us the activation or the muscle tone or the contraction of the muscles within a certain muscle. As you can see on this picture, this lady is doing biofeedback here, and the sensor would be placed on the muscle of interest, and she will be getting some cues on that iPad there that tells her to contract for a couple seconds and then relax. And she will be given different tones and different visuals that will tell her that she's doing good on contractions or bad on contractions. So these patients were, after occupational therapy, were given this EMG biofeedback to see whether this could increase the function, their hand function. And the specific muscle of interest here was the abductor pollicis brevis, which is the picture on the left. It looks like the thumb muscle right there. That was the muscle of interest that would help them regain their hand function. Moving on to our next group was the occupational therapy and then neurofeedback. So what neurofeedback group did was the 10 sessions of occupational therapy and then went into neurofeedback with the therapist. What this is doing those EEG scans. When you think of EEG, it's almost like a seismograph, but because we have such fast microprocessors these days, we use the power of the microprocessors to compile that data really fast. So we don't have to read this long script of this page after page of EEG data. It compiles that really fast and sends that results back onto a screen. You see there that it looks like there is a seesaw type game going on there. And what that game will display is positive or negative results of their EEG scans. So the EEG scan is measuring the action potentials within a region. And what this is intending to do is to increase the action potentials within a local area of the brain. If we go back to the previous slide, we know that there's localization of the brain. And if we can target the area that is most likely damaged, which would be the sensory motor region of the brain, then we can subject neurofeedback to that region to hopefully increase the action potentials within that region, which could ultimately increase the motor function. So this was the golden neurofeedback group that they did 10 sessions after their 10 sessions of occupational therapy. So for results of all of our groups, so the occupational therapy group by themselves, they were just the base level results. And the base level results was that they regained their hand function. If we move on to our occupational therapy, as well as our biofeedback group, they increased their muscle function within their abductor pollicis brevis muscle, but they had overall the net gain in function was pretty much similar to the amount of function regained by the occupational therapy alone group. And then moving on to our neurofeedback group, they increased action potential activity. So this was measured with their spectral power density. This is a very complex function that they had within their paper. But to summarize, what it did was it showed the level and the intensity of the action potentials within a given frequency. So within a given time, the power or the amplitude of the action potentials read by the EEG increased. So this would show that there's an increase in action potential activity, which could prove more activity within that region. So all of these groups showed pretty similar net goals. And this could be due to the biofeedback group only targeting one muscle instead of all the muscles in the hand. And the neurofeedback group, although they increased action potentials, there could be more of a less of a local issue and more of a delocalized issue within the brain that's causing the lack of hand function, as well as the area that's targeted by the neurofeedback could not have been the area that the stroke had happened in. So the paper suggests new protocols for biofeedback and neurofeedback just to be potential viable options for therapy for stroke patients.